Yeah, so we go back or forward to higher redshift, and in the future, just as we talk about JWST, and I would, in these 15 minutes, I would like to give an overview about the multi-object spectroscopic GTO program with NIR Spec on JWST, which is composed of two main components, the JADES and wide surveys that I will describe in a few minutes. Just to mention that this is on behalf of a relatively wide collaboration of several people. Now, NIRSpec will be the first multi-object spectrograph in space, and will enable, together with JWST, a leap in sensitivity, especially in spectroscopy, and especially in some spectroscopic bands, some wavelengths, by orders of magnitude. And this has happened very rarely in the history of science. I often like to compare these as equivalent to suddenly passing from Galileo telescope to modern large telescopes. So you can get a sense of that, what is the potential new discovery space that is opened up by JWST, especially in the spectroscopic modes. So the multi-object spectroscopy with NIRSpec is enabled by, as you may know, by an array of about a few hundred thousands microshutters, and you open them on the targets of interest, and that's how you get multiple spectroscopy. This is an example of a spectroscopic observation on the Hubble ultraviolet field, where we could open shutters on about more than 200 galaxies with the low resolution prism mode, so that the spectra do not overlap. And you see many of these galaxies are as faint as or fainter than 27 magnitude. And you can see each of the individual continuum spectra are traced by these tiny tracks surrounded by the continuum. In some cases, you also see emission lines. And each of these spectra cover simultaneously the wavelength range from 0.6 to 5.2 micron, which is, I find, always impressive. And this is the equivalent simulation with one of the three medium resolution gratings with the resolution about 1000. And in this case, we haven't closed any shutters, so we use the same configuration for the micro shutter array. And the consequence is that since the spectra in this case are much longer, that many of the spectra overlap with each other. However, since in this case we're mostly interested in nebular line emissions, whose filling factor on the array is very small, we don't really care much about the overlaps. We just want to exploit as much as possible, observe as many targets as possible. Of course, this will make the observations, the data processing and data analysis a bit more complex, but we have the machineries to deal with that. Now, as I mentioned, the survey, the GTO survey is consisting two main components. JADES is a joint GTO survey with the NIR Cam team, and NIR Cam will deliver fantastic, deep and high resolution images. I don't have at all time to discuss that. It would deserve a completely separate presentation. Here we'll focus mostly on the multi-object spectroscopic component, given that this is a spectroscopic survey conference. NIR Cam, of course, will provide the pre-imaging for NIRSpec, and the two instruments will work also in parallel. So we will take fully, will maximize the efficiency of the observing time in these GTO programs. And in this tier, we'll focus on the goods fields, and we'll dedicate about 800 hours of observation prime plus 800 hours in parallel. We will also have the wide component of the survey, which, as the name says, covers a wider area of about 260 arc minutes in the candle fields. And here we dedicate about 100 hours of spectroscopic observation. This is an example of planning of one of the observations of the survey in one of the fields, particularly in good south. And so in red, you have the red tiles show the distribution of the NIR Cam fields, and the the same for the yellow tiles, while the blue and green tiles shows the distribution of the NIR pointings. And medium JWST means essentially that here we are targeting the galaxies which are, will be selected with NIR Cam pre-imaging, while medium JWST, HST are essentially parallel observations with the NIR where we will be targeting objects already known from HST. There is also a small MIRI component in parallel of some of the NIR Cam pointings, which I don't have time to discuss. Overall, the spectroscopic survey will be a multi-tier strategy, and summarized by this diagram where you have the number of galaxies on the y-axis and the limiting AB magnitude on this axis. So we will observe from a few hundred galaxies in the deepest fields up to several thousand galaxies in the wider tiers, with depth which are, these are the depth in with the prism mode in continuum, and the depth is, as you can see, are essentially unprecedented and far deeper than what you can achieve with current ground-based observations, which are essentially out of scales. Each of these numbers gives the time on target with the prism for each of these tiers. As you may know, the NIR has various dispersers, a prism which covers simultaneously the entire wavelength range from 0.6 to 5.2 micron and is optimized therefore for detection, for instance, of continuum, while there are 3 medium resolution gratings optimized, which are optimal for the detection of nebula emission lines, and 3 high resolution gratings, which are of course more relevant for galaxy kinematics and dynamics. And in the various tiers, we will essentially exploit most of these dispersers. In the deep fields, we will observe with the prism, with the 3 medium resolution gratings, and with the longest wavelength high resolution grating. The same for the medium JWST tier. And with the medium HST, we will only drop the high resolution grating, while with the wide, we will observe with the prism and the 2 high resolution gratings. So we will have a broad mixture of all possible combinations of dispersers. In summary, we will observe more than 10,000 galaxies, exploiting a total of about 900 hours of spectroscopic observations, and over an area of about 300 square minutes, and down to a continuum sensitivity of about AB 28.5, and the line sensitivity of down to a few times 10 to the minus 19 erg centimeters per second per quadratic centimeter. And I think it's important to highlight that a few of these fields will be released very quickly to the community. And this, I think, is of interest of many of you, I guess, and how many and which of them will depend on the scheduling that we do not yet know. This is an example of a simulated spectrum with the various dispersers of a galaxy at redshift about 9.5 and fainter than the 27th magnitude. You see the red spectrum shows the simulated prism spectrum, which has a high detect the continuum at a high signal to noise. While with the 3 gratings, which are these 3 different colors, of course, they are not sensitive, that sensitive to the continuum, but they are great for detecting the various nebula lines, and we expect to detect several of them, metal lines, hydrogen lines, which will be used to characterize the physics of these early galaxies. And of course, we will have interloopers in terms of lines which comes from overlapping spectra, but we know where they come from, so there will be no ambiguity in terms of identifying them. Of course, with JADES and WIDE, we will explore star formation and galaxy evolution from cosmic noon all of the way to the earliest epochs of galaxy formation. In particular, we are selecting galaxies with redshift higher than 1.5, and we hope to observe galaxies out to very high redshift. How high, it depends on how the universe will collaborate, because we don't really know how far we can go essentially we are essentially entering into uncharted territories, so it's difficult to provide detailed predictions, but essentially we certainly target all of the galaxies that NIR Cam will identify as potentially at very high redshift. Of course, we'll be probing the buildup of stellar mass and metals across the cosmic epochs. And this is an example of how we expect to recover, thanks to this impressive statistics and sensitivity, the mass metallicity relation between redshift 4 and 6, which is totally uncharted territory in terms of mass metallicity relation, and also the function of star formation rate. Of course, you want also to go and possibly probe even more pristine galaxies, all the way possibly to even population 3 galaxies. And of course, we know that population 3 galaxies are probably very faint and extremely rare because the metal enrichment is very fast. However, we also expect that population 3 are expected to be very bursty, so there is the hope to detect a fraction of them in their bursty phase. And if you can detect them with NIRSpec in particular, then it will deliver a wealth of spectroscopic diagnostics to characterize this primeval population, for instance, their AMF and other physical properties. Of course, we also want to investigate the buildup of black holes. You know that the finding of supermassive black holes already in place at redshift between 6 and 7 and beyond is actually challenging for many theories of and models of galaxy formation and black hole coevolution. Many of them postulate the existence of different kind of black hole seeds in the very early universe and different ways on how they evolve. And one of the goals is, of course, to test these theories by directly detecting the early accretion on these seeds, small black holes in the early universe. And this, for instance, is a prediction from a model on the evolution of one of these black hole seeds between redshift 16 and 10. And with the sensitivity of the wide and JADES survey, we expect to detect a few of these, at least a few of these primeval black hole seeds, and therefore constrain these different scenarios. Of course, with the high resolution component of the survey, we will characterize in detail the shape of the nebula emission lines and detect possibly the presence of wings, which would be tracing galactic outflows, and therefore we will be investigating the early feedbacks in these galaxies out to very high redshift and given the resolution of JWST, also on sub-kiloparsec scales. And on the other hand, the low resolution prism component of the survey is exceptional in terms of sensitivity to the stellar continuum, and therefore we expect to probe the emergence of to identify and confirm the presence of passive galaxies and characterize them out to very high redshift. And I'm showing here this very nice work by Paolo Santini, where they predict that in the JADES surveys we should be detecting from a few tens to a few thousands galaxies at very high redshift. Of course, this is for the imaging component of the survey, but with the spectroscopy in the prism, we expect to detect and characterize several of them. There are, of course, several other science cases which investigated in the escape fraction of ionizing photons, the evolution of a neutral component of the IgM, ionization bubbles, physics of the ISM, dust attenuation evolution, you name it. I don't have time to go through all of these. Instead of going through additional science cases, I just wanted instead to mention that the multi-object survey will be complemented with another component of the GTO NIRSpec program, which will use about 275 hours to I'm done, to observe with integral spectroscopy more than 40 galaxies at redshift between 3 and 9, both with the high resolution and low resolution mode, with exposure times that will make this observation quite sensitive, and this will provide detailed three-dimensional information on the distribution of star formation, galaxy dynamics, outflows, stellar populations, with unprecedented sensitivity. So I finished here. So this is a summary for you about the JADES and why the multi-object component of the GTO program, and also the NIR component of the GTO program. I just want to finish by emphasizing that these extensive observations and extremely deep observation will have a very broad range of cutting-edge science cases, will leave a huge, have a huge legacy value. And again, I think it's important to remark that we hope to have a few of these fields already released very quickly to the community. And I'm sorry, we can't give a schedule and more details about this because it depends on the scheduling, which we don't know yet. And of course, later on, everything will become public. And the plan is also to deliver to the community high-level products on some time scale that we have still to identify. And I think I will stop here. Thank you.